Okay, so let us start. So today we will move to a very important package when you do machine learning and data analysis. It's called NumPy package. NumPy package. Okay. It's mostly for numeric calculation. It's very important. And in NumPy, the array class is called ND array. Okay, ND array. So we will take a look. And we're just going to go over, because it's one class time, so we cannot go to too much detail. So to use NumPy, you need to import it. So that's the very first thing, you need to import it. And normally what we do is you import as NP. And to create an array, so here NP dot array. So this is to create a NumPy array. And who still remember the square brackets with some items in it? What is that? Who still remember? Last class we discussed. Very good. List. Yeah. So here you can create a NumPy array with a list. Okay, with a Python list. And here to create, so this create an integer array, and here you create a floating point array. And then over here, so the parentheses, who remember the parentheses include, what's the data type for parentheses? Last class we also learned. What is that? The parentheses, within parentheses, what we learned last class in Python for container data structure. List. What is it? Parentheses. Who still remember parentheses? Yeah, very good. Tuple. Yeah, that's tuple. Okay, remember. Is tuple mutable or immutable? Is tuple mutable? Can I change this tuple 1.5 to 2.3 to negative 1.5? Can I change it? Can you change tuple? Can you change a tuple? Can you modify a tuple? Yes, you can. That's the wrong answer. Get points off. No, tuple is immutable. Okay, keep that in mind. List is mutable, but tuple is not. You can never change a tuple. Keep that. But here, what it shows is you can create a NumPy array with tuple also. Okay, and here, did you see? We have a tuple. We have another tuple, but outside of the tuple, we have what? So outside of the tuple, we have what? It's a list. So within the list, we have what? We have two tuples. So this will give you what? A two-dimensional array. This is a two-dimensional array. Okay, did you see? So this is row 1. This is row 2. And here you have column 1, column 2, column 3. So this is a two-dimensional array. And for complex, we just ignore, okay, because we are not going to use it. And the next function is NumPy arrange function. So this function can return array with a sequence of number. So here it's syntax. It's you give the starting number, ending number, but be careful, ending is excluded. And the step. The third one is a step. So that's why did you see the result is 10, 15, 20, 25, every 5. So you can specify with the arrange function. And the next one, this is also quite useful. It's called line space. So line space is you can specify how many numbers you want to generate within a range. Okay, quite useful. And what here it shows, you can see this is very nice compared with other programming language. Okay, for other program, you cannot just use this one line to do sign for every single, for all of the item. You need to use a loop. But for NumPy array, did you see you can directly apply that function to that array? Then it will automatically, so the return value is still an array. So it will, so this function, we call it broadcast rule, and it's element wise. So in NumPy array, the operation is element wise. So even though, did you see, you pass in an array, it will do the sign operation on every element of the array. That's why we call it element. In other point, you cannot do that. Is it? So think about in Java, can you pass an array into a sign function? You cannot. You need to use a loop through the array and then element by element. You can use for each loop or regular for loop. But anyway, you cannot do something like this. This is the benefit part of Python. Not Python, the Python's NumPy package. Okay, it's element-wise broadcast. Okay, so here you don't need to write a loop. So how nice it is it? It's just kind of like save us a lot of work. So that's why here it says arithmetic operator on array apply element wise, and a new array will be created. Okay, so here take a look. We have these two arrays, A and B. These two arrays, and did you see? You apply a element, each element with a sign, and B with cosine. You just need to write, it's kind of a math formula. In math, we can do this. But we use what? We call that vector. And then you can plug in with vector in math. So here concept is kind of similar because vector in math concept here, it's an array, it's element wise. And next is about multiplication. So multiplication is also element wise for product operator. So this is kind of mathematics matrix operation. But here it's element wise. Okay, be careful. So this A times B is element wise. And A at B and A dot B, that's a different concept. That's dot product in math. Okay, we don't need to worry too much here. And the other operation plus, equal, multiplication, equal. Here, similar, if you recall last class, we discussed. So here it gives us an example. So here A is what? A is a two-dimensional array. So It says ones and with a tuple 2, 3. That's a two-dimensional array. That means it's 2 by 3, 2 row and 3 column. Okay. And then did you see it's multiplied by 3? So it's element wise multiplied by 3. And then B plus A. So this B and A both are array. In other point, you cannot do that. You need to do a loop. As if for two dimension, you need 2 loops. Inner loop and outer loop do element wise addition. But you see, NumPy, it's so nice, so cool. That it just you just write this single line, it will do the loop for you. The next shows us about it says unary operation like summation. So here the A, what is A? What is A? A is a two-dimensional array. So with random 2, 3, that tells you generate a 2 by 3 array. Generate a 2 by 3 array. That's what here is at. And then here is at A dot sum. So this sum will summation everything. So it will generate a scalar, a one number. But here, take a look. So this is important. The axis in NumPy array, very important concept, okay? Because later on, when we learn pandas, we also will see the axis. Because a lot of time when you do data mangling, you need to know on which axis it is. Okay, so that's why it's important. And here it says some axis is 0. Axis 0 is what? 0 is the first dimension. First dimension is row. Okay, so you are going to do addition for all of the row. So that means you are add the numbers for each column because you add each row. So it's for every column. So it will reduce. Did you see? So it will reduce the original array 2 by 3 to what? 1 by 3. So column number is the same, but row number reduced. It's add all of the numbers in each column. Okay, be careful here. And x equals 1. If x equals 1, that means you're going to addition what? Row. You add all of the numbers from each row. Okay, from each row. So that's why here the result is you only have 2 rows. So that's why you add all of the numbers of, you add all of the number from each column. Okay, from each column. So that's why you have 2 rows left. You reduce the column to 1 and you still have 2 rows. So this axis concept is very important. Keep that in mind, okay? And here, the reshape method. The reshape method can change. So NumPy array, the size can also be changed. So initially, this is one-dimensional. So it's 1 by 12. 1 row, 12 column number. And you want to change it to 3 by 4. Then you just call reshape 3 by 4. So did you see it have first row, second row, third row. Okay, and the first column, second column, third column, fourth column. So it's a 3 by 4 array. The next one is quite important. This dot dot and then comma. What is that? In other program, we never see this. That because within index, you can only have a single number, but you can see for Python, the NumPy is quite flexible. So what is this? So the comma, before comma is for first dimension. After comma is second dimension. Okay, so this means indexing. So this is starting column. So this column is column 0, column 1. So it means item of column. That means all of the row. This is the first dimension. The first dimension of the row. So this is called indexing. Okay, very important. In 2D, we can do this. So this is regarding first column, and this is second column. Oh, I'm sorry. First dimension and the second dimension. Okay. And similar, this colon. So colon means slicing. Okay, single number means indexing. Indexing just pick one. Colon means start from where, ending from where. So it's a range. We call it slicing. Okay, the word slicing. So here, we didn't specify start and end. So that means everything. So basically, this colon and the dot, 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 these two are the same. These two are the same. You can choose either one. Okay. And what the next one try to show us is still about this axis concept, the parameter axis concept. Okay, so here we have a 3 by 4 array. And that, if you take a look, this is a 3 by 4 array, ARR. And then you call the delete function on this array. And you specify the axis. The axis is what? Is 1. That means second dimension. So it's going to be a long column. And which column is specified here too. So the third column will be gone. So that's how you come up with this new array. And it doesn't have the third column. Okay, so here you see, because when you later we will see 3 dimension, maybe 4 dimension. Is it because in the real world when you do it's multi-dimension. So that's why you need to specify that axis. You do operation on which axis. So that's important. Okay, be careful here. And here we do mean axis is 1. So axis is 1 it means what? It means you are going to do mean. You add all of the column numbers. You do mean of the column. So that's why the result will be on each row. Is it? So you sum all of the row, each of the item from the first row, and then divide by 4. That's why it's 1.5. The row number, we have 3. That's why the result is 1 by 3. Is it? So it's reduced from 3 by 4 to what? To 1 by 3. Is it? So basically to keep the 3 rows. And similar for the sum, axis is 0. That means you are going to do addition for each column. Addition for each column, okay? That's why here you have 4 results. And what is the next one? It's called COMSUM. So what is this concept? It's a cumulative summation. Okay, so if you take a look at the result, what is B? B, where is B? I forgot where B is. Okay. And so anyway, let's insert above. Let's see B. I needed to run all of the cells above. And then let's see what B is. Okay, this is B. So what is this COMSUM? It's a cumulative summation. It's along what? Along x equals 1. Is it? So along column. So did you see it's 0 and then plus 1 is still 1. Here is 2. It's adding the previous to 2. So that's how it comes 3. And this 3, add this 3, that's why it's 6. So along column, did you see that's called cumulative? You add the previous summation to the current one, cumulative. And the next one is 4. And then 4 plus 5, that's why it's 9. And 9 plus 6, that's why it's 15. Okay, so this is called cumulative. Okay. Okay, the universal function, we already see some of the calculation, sine, cosine, and here's also giving exponential. Anyway, they are called the universal function and operate element-wise. Okay. The result is still array. The next one, indexing, slicing, and iterating. Okay, very important concept. Because later on, next week, we are going to learn pandas. Data frames are similar concept. And it's very important in machine learning, also because in machine learning, you are not going to use the huge data. You're going to pick part of it. How do you pick part of the data? How do you do data cleaning? That's part of machine learning's job. So let's first take a look. This A. A is an array. What does the array look like? It look like this. So it's some numbers, okay? And then be careful here. Within array A, it included another array. Okay, it's included another array. That array is what? It's 1, 3, and -3. It's an integer. So what does that mean? So basically, within an array, and then you pass in another array with the square bracket. So this is called indexing. You plug in with another integer array here. Be careful, it's integer array. So that means you're going to take what? The second number. Did you see the second number? The fourth number? What is -3 mean? Last class we learned. Why we can use negative for indexing? Who still remember? -3 means what? What does it mean? Oh, forgot. We will have this quiz. What -3 is? Here. When you have a negative integer number serving as index, what does it mean? Anyone still remember? Forgot? Means you count from. Normally, when we do count, we count from what? From beginning. When you have negative, you count from what? From n. Is it? So -3 is what? It's the third last. That's why it is this number. Okay, so this just means, oh, oh, I got it. I even don't know where that is. Is it this one? I believe it is this one. That means it gets some numbers from the other array. Okay, so this is called indexing. Be careful. And here, this is just purely assignment. You assign a single number. So the first number, did you see it's a chain? Okay, and then over here, what does this mean? :6, :2. That means you do slicing every 2 number. You change every 2 number to -1000. That's how. Did you see you change it to -1000? And this is just regular indexing. And what does this mean? For one dimension, it's just the same. If it is 2 dimension, then it's different. Okay, so be careful. And this is just a list of the numbers. Then what does this mean? You say ::, -1. That means you reverse. Okay, you reverse. So the above this, we see some examples about indexing and slicing. Okay, very important concept. And what is the next one? We can skip it. Oh, sorry. The from function, we can skip it. What the next one showed ? Within bracket. What does that mean? Let's take a look. So here, be careful, okay? For this array, it looks like a 2-dimensional, is it? No, this is a 3-dimensional array. 3 dimension. This is the first dimension. So there are two two rows, kind of. So first one, second one. Okay, this is first dimension. What is second dimension? Within it, did you see? Here is 1, here is 2. So this is like the row. Oh, that the other one is the row. This is like column. Okay, so this like axis, and here is y-axis. And what is this? This 0, 10. That's the z direction. Okay, so be careful, okay? This is 3-dimensional. Okay, 3-dimensional. So what the shape is? It's 2 by 2 by 3. So x-axis, you have 2. Y-axis, you have 2. Z, you have 3. Okay, so be careful here. It's 2, 2, 3. Then let's see what this means. This means indexing. It's 3-dimensional. It's 3-dimensional, is it? So the first dimension, you take what? Take second one. What is second one? It's this one. For the second dimension, it take everything. So that's why these 2 rows will be taken. For the third dimension, because dot, 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 it also take. So that's how the result is there. That makes sense? This makes sense? Okay, then next, let's take a look. So that comma 2 is for which dimension? Anyone knows? Anyone can guessing? The comma 2, dot, 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 comma 2. 2 is for what? Third dimension. For the first dimension, it takes everything. So all of these 2 brackets will be taken. For the second dimension, it will take everything. So each individual brackets will be taken. For the third one, you take what? Take 2. 2 will be what? Will be the third column. So it will take 2, 13, 102, 113. See? So that's why it's reduced from 2 by 2 by 3 to what? To 2 by 2. You see it? So in later on, when we manipulate data, that's how you need to know how to do all of that. Okay, it's quite important concept. And next, let's see. What dimension is this? This is also 3-dimension. Okay, 3-dimension. And it will take the last dimension, take what? Take the second column. That's why it take 2, 5, 8, and 11. Okay, for the other 2, that's take everything. But then for the third, so you can view it as X, Y, Z. Okay, in the 3-dimensional world. And to loop through array, you can use the for each loop. And if you want to flat a multi-dimensional array, you can just call the flat. It will give you a 1-dimensional array. The next one talks about shape manipulation. So for NumPy array, you can change the shape. Okay, so there are 2 function ravel and reshape. Ravel will flatten a multi-dimensional array to one-dimensional array. Ravel. Okay. And the reshape can change it to any dimension. But they do not change the original array. Be careful, okay? There is another function it can change the original. This only work on its view. And we can take a look. So here, we call NumPy random function. And this will be a integer, random integer number. And you're going to generate a 3x4 array. So this is 3x4 array, or 3x5. This is also 3x5, 3x5. That's a different random generator. And then let's see, if you call ravel, what you will get is get flattened. But you can call reshape, did you see? So reshape 3x4 to 6x2. Yeah, did you see? You can also read a lot of time. We need to do that. And the ratio won't impact the original array. But there is another function called resize. If you do resize, it will impact the original. So A, did you see it will be changed? Okay, for reshape, then it won't change. So be careful about this. Okay, the next one is if we have multiple array, how do we combine them together? So we can do vertical packing, so we call stacking, or horizontal expansion. So you can do either way. So that's why we call it stacking together multiple arrays. So how do we do that? Let's see. So we have A and B. So this is A and this is B. Both are 2x2. And when you do, did you see called V stack AB? That means you got vertical stack, vertical expansion. That's how you come with a new array that's a 4x2. It's a 2x2 vertical. Then it's changed to 4x2, okay? And you can do H stack. So H stack will horizontal. So 2x2, then you pack them together, it's 2x4. Is it? It's 2x4, okay? Okay, we can skip the remaining part. It's a similar concept. The next one discusses split. Split. So previously discussed concatenate multiple array together. Here you get a big array, you can divide it into multiple arrays. So we can call like over here you have A. A is what? Is a 2x12 array. And if you call the split, H split, and provide with the number, that means you want to divide it into 3 arrays. So that's how you come with new array as 2x4, 2x4. So what the next one is copies and views. Okay, copies and views. So let's see, A is an array. It's a one-dimensional array. B is A. So basically, A and B are the same thing. They point to the same memory location here, even though they have 2 different names. Okay, this is just like You see, we can name Bob and the robot. It's the same thing, is it? And if you change B's shape, A's shape also change. And the next, let's see. When we slicing an array, it says it returns a view of it. So let's see over here. S is A. It has colon for first dimension. And the second dimension, you also have colon. And why we know that? Because here we have comma. Okay, so what does this mean? It means this is A. This is A. Okay. This is A. And for S, oh, let's do this. Where I'm sorry, here is A. This is A, array A. And the S is what? For first dimension slicing, first dimension is row 0, row 1, and row 2. Is it? So you have 3 rows. So this colon, without starting, without ending, that means all of the rows. So for first dimension, we are going to take all 3 rows. For second dimension, when we do slicing, we will not consider first. We're starting from second. So starting from 156, 159, so 2, so 0, 1, 2. 3 not included. So you are going to get 159, 2, 6, 10. That's what your S is. And you're going to change this square and this whole section number to what? To 10. Did you see? That's how we get this 10, 10 in the middle 2 column. That makes sense? Yeah. So the benefit for slicing, a lot of time, you want to change part of your array. Is it a section of your array? And of course, you can do one by one, but that's too tedious, especially if you have if you have a big array, that's hard to manage. But you see, you can use a slicing technique to do that. You get out of part of it. Is it? Yeah, so here it shows us this technique. It's quite useful, okay? So view basically is still considered shallow copy. Anyone knows the difference between shallow copy and deep copy concept in programming language? What's the difference between shallow copy and deep copy? Shallow copy basically is it a copy? It's not a copy. It's just the object itself. Deep copy is the real clone. Okay, so that's a difference. So when you really want to have another clone, you can call copy. Otherwise, previous what we discussed, it's view, it's still the object itself. Okay. Oh. Okay, what's next discussed is about advanced indexing. Very nice idea. Let's see. What is A? A is a 3 by 2 array. Is it? It is 3 by 2. First row, second row, third row. There are 3 rows. 3 rows of this array. And 2 columns. Each row has 2 columns. Is it? And take a quick look at this. What does this mean? Is it weird? You have an array, then within array you have that complicated stuff, what that is, and with a comma. Because this is 2-dimensional. So you have the comma, is it? So on the comma left, it's for row number. This is indexing for the second dimension. Okay, so this is indexing. So basically it tells you what? Tells you this is the first row, first column. So which number you're going to get? That's why you're going to get this 1. That makes sense? The second, you're going to index 1 and 0. 1 is what? Is this row. Which column? First column. That's how you get to 3. Okay. And the last one, you get 2, 1. 2 is row 0, row 1, and row 2. And then this is row 2. Which column? Column 0, column 1. So that's how it comes with the 6. Okay, so did you see? So NumPy use this kind of indexing to extract numbers. Okay, so there are multiple ways. We can do slicing. We can do this kind of advanced indexing. We call this advanced indexing. What next one is Boolean indexing. So what is Boolean indexing? So here is an array. A is an array. Did you see? Within the brackets, what do we put? We put a condition. For a condition, you get what? You get true, false. So basically here, it want to get off the numbers that's greater than 50. Did you see how nice it is with NumPy? You just put that condition in its bracket. You don't need to write a loop to do this 1 by 1 check. So that's why NumPy array, if you want to do numerical, it's very fast, very efficient. Okay. And for the next one, did you see? The condition is you do module and check if the remainder is 0. And what the next one shows is you have a 3 by 2 array. And then you do what? You do sum. It's row sum. This is row sum. Okay. And after that, you want to know which row sum is the remainder is 0. If it's module 10, then you can get the number out. Okay, so that's regarding the advanced indexing. What next shows its fancy indexing and the index tricks. Let's see, this is a 8 by 4 array. So 2-dimensional. What does this do? This is indexing. If you have a 2-dimensional, and if you do the indexing, the result can still be a 2-dimensional. It's just reduce the dimension the x dimension or y dimensions number. Okay. So over here, for this indexing, then you reduce the original from 8 by 4 to 4 by 4. So what does this mean? It's all for one dimension. Dimension 1 is that for dimension 1 to get to the second, and then it get to the fifth. So 0, 1, 2, 3, 4, 5. It will get this one. Next, get to 7. Get this one. And then get 2. Get 8. Did you see? That's how the result. So you can also kind of rearrange this array. Okay. And let's see, it's much more interesting for this one. So here you have the comma. So before comma, it's regarding row. After comma, it's regarding column. So let's see. So here you have 1, 0. 1 and 0, so it's full. Is it? 1, 0, it's full. Okay. And then you have 5, 3. 0, 1, 2, 3, 4, 5. 5 and 3. So that's how you get 23 out. That makes sense for this one? How the indexing works? This we call it fancy indexing. Okay. So I'm not going to go over the remaining. The next one is even more interesting. For this one, you first need to take, this is a whole section. This array, AR2, it's got indexing. So this indexing, 1, 5, 7, 2. You get this part. Is it? You extract some row out. After you extract some row out for this array, what are you going to do? For this 2 dimension, did you see? For the first dimension, it will get all of the row out. Is it? So here, colon, just colon means everything. And for column, did you see? Okay, for column, then 0 is still 0. So that's why the first column is still here. Then it said get the third one, so 7, 23. So it moved the third to the second. Okay, so here it rearrange the column. So you can also rearrange a column. Is it like this? So it's very neat, very useful. Okay, the next one is still the advanced indexing. So here for A, we have this number. We have 5 number array, is it for A? And I is what? I, you have, it's also a NumPy array. Then you said AI. So what is that? Is it, what is that? A sub I. Is it, okay, for A, you have 12 numbers. There's 12 numbers. And AI, you want to get 1, 1. So 1, and then 1, repeat. And then 3, that's 9. And 8, 64, and 5, 25. That's it. So this I is indexing. The next one, let's see, it's also interesting. So this is also regarding color. So here you define a palette, color palette, and here is some image. Okay, with the NumPy array, and then you say, okay, palette image. Let's see, what does that mean? So palette, the first, the image is at 0, 1, 2, 3, or 0, 1, 2, 0. What does this mean? It's from palette. So palette, this is its 0. Row 0, row 1, row 2, is it? So it says 0, okay, 0. And 1, that's 1. And then 2, okay, then 2. And then 0 again. Then 0 again from palette. So it extracts the respective row out and rearrange it as a dimension. Did you see it as a dimension? And the same thing come up with the second dimension. So here, the original palette is just a 2-dimensional array. So it's 1, 2, 3, 4. It's 5 by 3. Now, did you see? What is this array? This is a 3-dimension. You change from 2-dimension to 3-dimension. You can also expand. Is it? With the fancy indexing. That's how you define the image, the pixel color. Just think about this is practical, very useful. Okay, because palette is the color element, like red, blue, green, yellow, you know. And all this based on 0, from number 0 to 255. And so why here we have it's RGB color. Okay, each component. So that's why you have 0, 0, 0, or 0, 20, 55, and 0. That's RGB channel. And you have pixel, each pixel, is it? And your image is a 2-dimensional. And that for 2-dimensional, it's a 2-dimensional image. And then each pixel itself is also a color component, is also an array. So that's why here, for a real image, basically it's a 2D image, it's a 3-dimensional array can represent it. Okay, so be careful here. How do we come up? Because you see, in machine learning image, how it deals with each pixel. Okay, deals with each pixel. Okay, so that's regarding, we can skip the not too important. Oh yeah, the next one, this is quite useful, argmax in NumPy. Okay, very useful concept. So let's see. Time is what? This is time. The data is what? Data is this 5 by 4 array. And then you said data.argmax. and the axis is 0. So what does this mean? That means you want to find out the index of the maximum number along each column. You want to know the index. You want to know the location, not the number itself, the location where it is. Then you use this argmax. It will give you the location right away. It's a very, very nice function. Okay, keep that in mind. Very useful. It can help you locate where the largest number is. You see, the first column is this number. That's how the result is 2. Did you see the second column is the first one, 0. That's how it comes with 0. Is it? Because why did you see? Once you locate where the number is, then you can get the number. So if you know the index, then you know the number. That's why we see this is very important. Keep that in mind, okay? And once you get the index, then you can get the number out. So here it shows us how you extract the number out. And of course, you can also call this function using max function. But using max, the difference is it only gives you the maximum. It didn't tell you where it is. So if you want to know where it is, you need to call the max. An index with Boolean array, you see it can return you a Boolean array, okay? And the next one we can skip. The remaining part, let's just skip it.